Okay, for today's Sciencemancy, we'll do AI and fleets of small drones. And besides the sci-fi possibilities that the authors lay out, we also learn about what these drones learn from the vision of insects, as well as the three laws of bird flight that allow for flocking behavior. I'm Lex Pelger. I do Sciencemancy. If you go back to the original post, you can choose a topic for me to cover. I will start by reading their long paragraph on all the possible scenarios we might have coming of what you can do with a fleet of drones. But if you have any sci-fi ideas, I would love to hear them. Of course, the first obvious application being pornography. Wouldn't that be amazing? A fleet of drones for your porn scene? Also, just keep in mind, as this article points out, there would be three levels of potential control here, too. You have drones who are responding to direct signals, ones that are somewhat interacting with their environment, and completely autonomous fleets of drones that are using AI to make all of their decisions together. So who could this be useful to? For farmers, you could have flying cameras and cloud-based data analytics that allow them to continuously monitor the quality of their crop growth. You could also use these kind of platforms for construction companies to measure work progress in real time. Drones will help mining companies obtain precise volumetric data of excavations. Energy and infrastructure companies will be able to exhaustively survey pipelines, roads, and cables. Here's an interesting one. Humanitarian organizations could immediately assess and adapt aid efforts in continuously changing refugee camps. Transportation drones that are capable of safely taking off and landing in the proximity of buildings and humans will allow developing countries, those without a suitable road or rail network, to rapidly deliver goods and to finally unleash the full potential of their e-commerce telecommunications infrastructures. Transportation drones will also help developed countries to improve the quality of service in congested or remote areas and will enable rescue organizations to quickly deliver medical supplies in the field and on demand. Inspection drones that are capable of flying in confined spaces will help firefighting and emergency units to assess dangers faster and more safely. Logistics companies to detect cracks in the inner and outer shells of ships. Road maintenance companies to measure signs of wear and tear in bridges and tunnels. Security companies to improve building safety by monitoring outside the range of surveillance cameras. And for disaster mitigation agencies to inspect partially collapsed buildings where ground clutter is an obstacle for terrestrial robots. Coordinated teams of autonomous drones will enable missions that last longer than the flight time of a single drone by allowing some drones to temporarily leave the team for battery replacement. Drone teams will permit rescue organizations to quickly deploy dedicated communication networks for ground operators, and telecommunication companies can also leverage drone networks to temporarily supplement or replace points of service. So how will the vision of these drones learn from insects? Well, for one, insects use compound eyes, which have these dense array of facets that point in many different directions and span large fields of view. And that's really helpful for flying in cluttered environments. But how they process that information is what's the really cool part. It's called optic flow. And the means that the data coming in their brain is generated by their own displacement relative to the surroundings. And it produces a large variety of flight capabilities, such as obstacle avoidance, speed maintenance, odometry estimation, wall following, corridor centering, altitude regulation, orientation control, and landing. So they're actually using their own brain, knowing how fast they're moving, and scanning the whole environment using compound eyes, and they learned how to do this from insects. Then for that difficult problem of a whole bunch of drones together in a flock and not having them hit each other, it turns out using computational models of birds, they realized that there are three basic rules to how birds flock that keep them together without collision. And that is repulsion from the nearest individuals, movement towards the farthest neighbors, and alignment with average velocity of neighbors. And with those simple rules, you can generate the basics of what flocks do. And they also talk about if you can't see them in certain environments, drones will be able to use hearing as well. And so this stuff is getting closer and closer to being a reality, and it's going to open up all kinds of things in all kinds of fields. So if you have any thoughts on it, I'd be quite interested.